Hello. Right, what we're going to do is have a look at some integration. We're going to look at some basic integrals, okay? That is integrating some standard results. So I'm just going to take a few of those questions and go through them with you. So the first one is integral sine 3x subtract 5. Now, when you integrate something like sine u with respect to u, you should be aware that you get negative cosine u plus c. Okay. Now, if you replace that letter u with, for example, 3x subtract 5, it shouldn't surprise you that in your answer to integral of sine 3x subtract 5, you should get something like negative cosine 3x subtract 5. Okay, so our answer to our question, you know it's going to be something to do with negative cosine 3x subtract 5, and there will be a plus c, of course. It's just that there might be some coefficient in front of this. Okay, well there will be, and we're just going to check to see what that is. Well, one way of checking is by differentiating our answer, because the great thing about integration is you can always check your answer by differentiating and see if it's the same as the question at the beginning. So when we differentiate negative cosine 3x subtract 5 using the chain rule, you should get positive sine 3x subtract 5, and when you differentiate what's in the brackets, you get 3, so that'd be 3 sine 3x subtract 5. And of course that's not what the question is. Our question is just sine 3x subtract 5. So what do? We just multiply our answer by a third. The reason we multiply it by a third is because if we just divide the x by 3, we'll need to change y by having that as a third at the front, okay? And so therefore, in order to get our required result of sine 3x subtract 5, we have 1/3 here as our coefficient. So our answer should be negative 1/3 cosine 3x subtract 5 plus c. Okay. Alright, let's just get rid of that. If you want to do a similar one of those, you can do that quite easily. And just put up a different integral. Okay, and just change the colour while I do that. So if I wanted to integrate cosine, let's just choose a different number, 7x plus 2 dx. Okay. Using a similar technique, you know that when you integrate cosine, you get positive sine. So you know your answer's got to be something to do with sine, and then the angle, the brackets that is 7x plus 2. You know there's going to be a plus c, so just put that in before you forget. I wonder if you can tell me what the coefficient in front is. Okay, this bit here. It should be 1/7. Okay, because when you differentiate this expression, you see, using the chain rule, you're going to have to differentiate what's in the brackets, you see. Differentiate the brackets, you get 7. So when you multiply the beginning by 7, you're going to get the 1 times cosine 7x plus 2. Okay. So one simple way of remembering what to do is to look at the brackets, and if you want, apply a reverse application of the chain rule. Okay, that is, going back to my original question here, if you know the answer is going to be something to do with cosine 3x subtract 5, you just differentiate the brackets to get the 3, because you're integrating, divide by 3. And let's see if we can apply that rule with the next question, which is integral e to the 3x plus 2. Now, with our differentiation of e to the power of x, you know that the power doesn't actually change, so you should be prepared for the fact that the answer is going to be something to do with e to the 3x plus 2. And there's a plus c as well, of course, but to get the coefficient of that, what you do is you differentiate the power, because in this case the bracketed term is effectively the power, although you don't need to write the brackets. You differentiate this expression here and you get 3. So normally in differentiation you multiply by 3, but integration you divide by 3. So your answer is 1/3 e to 3x plus 2. And if you're not too sure about that, you can check by differentiating. So that's quickly done, you see. If y is 1/3 e to 3x plus 2, I won't put the plus c, then dy dx is going to be equal to, and then let's differentiate that, so 1/3 e to the 3x plus 2, because the power doesn't change, differentiate the power, you get 3, so times that by 3, and you can see you get e to the 3x plus 2. So that checks that works for us. Okay. All right, let's have a look at a couple more examples. Well, this one here, first of all, integral sec 5x tan 5x. Now already you might be thinking, oh crikey, that looks a bit difficult, doesn't it? Not quite the same as what we've been doing, but that's just setting this tone for this chapter. This is the final integration chapter, so you can learn a lot of different key integrals, a lot of key techniques. Actually, this is a simple question. Okay, what you need to do, maybe, if you're seeing this for the first time, you look back at the key standard results, the standard integrals at the beginning of the chapter. Okay, and somewhere there in the list, I can't remember which number it is now, there's an integral of sec x tan x dx is equal to sec x plus c. Why is that? Well, because when you start off with y equals sec x, you should recall from the differentiation unit that the derivative of sec x with respect to x is sec x tan x. And you can prove that if you want by using the chain rule. You just write sec x as cosine x to the power of -1. Okay. So bear in mind the derivative of sec x is sec x tan x. In reverse, then the integral sec x tan x is sec x plus c. Okay, so let's just get rid of that. So what we have in our question on the left here is sec 5x tan 5x. Well, the angle's different, that's all. But to be honest, this x here could be 2x, 3x, 5x. You just use the angle that's given to you, and so you know the answer is going to be something like sec 5x plus c. I'll say something like because you just need to, again, work out what the coefficient is. I wonder if any of you can tell me what you think the coefficient is. Yes, for those of you who got it. And for those who didn't, try and work out why that is. Okay, it's 1/5. Hopefully you're thinking if you differentiate that I've just underlined, the 5x, you get 5. So integration, you divide by 5. And that's where the 5th comes from. If you're not too sure, what you do is you differentiate that result. If you differentiate 1/5 sec 5x, hopefully you can see that when you do 5 from the 5x times by 1/5, you get 1. It cancels, you see. So those are fairly simple questions, okay? And if you check out that list of standard integral results, you need to know them all. You need to be able to use them all as well. Let's have a look at another one. Right, a different one again, okay? But this is what this chapter is going to be like. You'll get so many different integrals, and you'll get fractions, you'll get trigonometry, you'll get exponentials, natural logs will appear there somewhere as well. Yeah, and you've got to be able to handle all of them, okay? Right, this one. Well, let me just take you back to an integral from much earlier on. You should remember that the integral of 1 over x dx is natural log of x plus c. Okay. So what's different about this? Well, instead of 1 over x, if you had 1 over u du, you'd get a similar thing. You get natural log of u plus c. So what we're looking at is here we've got 1 over something, okay, and that something for the moment I'm just going to say is a linear term, okay. When that happens, you know that the answer is going to be a natural logarithm, okay. For reasons I'm going to go into later, I'm going to put this 7x minus 1 into modulus brackets, okay. You'll see that later on, but it's to do with when you put in limits, okay. You can't evaluate the natural log of a negative value, okay? So you need modulus brackets around there for when you deal with the limits, okay? I'm going to put the plus c as well, in case I forget. Now let's just check that by differentiating. Let's suppose we have natural log 7x minus 1 as y. I want to differentiate that. We want to find dy dx, okay? Well, you should get 1 over 7x minus 1, of course, because when you start off with natural log of x, going backwards, when you're differentiating, you get 1 over x. So starting with natural log 7x minus 1, differentiate, you get 1 over 7x minus 1. But then as before, using the chain rule, if you differentiate what's in the brackets, you get 7. and so you'd have to multiply your answer of this derivative by 7. Okay, so you'd have 7, if I just write that there, over 7x minus 1, and then just compare that other answer. Okay, so you have to multiply that by 7th to get 1 over 7x minus 1, and so this here I'm writing in will be 1/7, so that means our answer is 1/7. So you can see it's similar to what we've seen already. Okay, that is, when you're differentiating using the chain rule, you multiply by the derivative of what's normally in the brackets, but in reverse, when you're integrating, you would divide by the derivative of what's in the brackets. Okay, let's look at the second one. So integral of 2 over 1 minus 2x. Well, if you want, just ignore the 2. You can write it like this though, if it helps you. You don't have to, but just recognize it as the same as the integral of 1 over something. Okay, and when that happens, you're going to get the natural log of something. Okay, and you're going to get the natural log of whatever the denominator is in these cases. Okay, there are other exceptions and other sorts of integrals that I'll go into later, but for the moment, when you've got a linear expression on the denominator, you're going to get a natural logarithm. Okay, let's not forget the 2. That was at the beginning. Okay, so you get 2 natural log 1 minus 2x. But you might be thinking, well, should there be something else that goes there as well? Yes, you're absolutely right, because when you differentiate what's in the brackets, you're going to get -2. And remember what you do when you're integrating. You could divide by that -2. So your answer will be -2. Let's just put divide by 2. Okay, let's make this line correct by putting the plus c. And then you get negative natural log 1 minus 2x plus c. And you can just check that when you're differentiating it again. If you were to differentiate this expression, you can see that the -2 here from the derivative side of the brackets multiplied by the -1 in front gives you +2, which is where that ends up. And of course, differential of natural log 1 minus 2x gives you the denominator there. I've made a mess, so I'm just going to clear that up a little bit. Okay. Yeah. Now, I'd normally say, are there any questions on that? But since you're watching a video, I'm hoping you'll just pause and replay the relevant bits if you do have any questions. But if you do, just drop me a line. Okay. I think there's one more. Yep, here it is. Well, straight away, it's not a natural logarithm. Okay. So here's what I'm going to do. Because that's not a natural logarithm term, I'll come back to that in a minute. Okay. I'm going to give you a general result that is very handy for you to write down when you integrate something to get a natural logarithm. Your general result is this, that if you have integral of, how shall I write this? Why don't I put 1 over ax plus b, okay, dx, and if the number on the numerator tends to be 2, 3 or 4 or whatever, you just multiply by that same number. Okay. Let's just see if you know what the answer is going to be. I'll give you a couple of seconds. And that's it. But frankly, that's all the time you've got in the exam for this sort of question. You need to know straight away that your answer is natural log of ax plus b multiplied by 1 over a, and then plus c on the end. Okay. Why is that? Well, because if you start off with y equals 1 over a, natural log ax plus b, when you differentiate, then using the chain rule, differentiates in the brackets, you get a, and the a times 1 over a just gives you 1, and so you get 1 and then over ax plus b. So this is a standard result that you need to know. It'll be an opportune point to pause the video there and make sure that's fully sunk in, or take a note or something like that. Well, I'll go back to this one next. Okay, this one here, you might think, oh, come on, you're giving us loads of different integrals now. But yes, I am, but like I said, yeah, there's a reason why the integration chapter is quite hard. Okay, and there's a lot of stuff that comes in thick and fast, and you need to know all the results for all of them. Okay. Well, no, the answer is not by expanding the brackets. You could do that, but because it's power 4, it would take you a long time. But imagine this was power of 10 or 20 or 14. Okay, you're not going to expand the brackets, are you? Okay. You need to have some sort of method of doing it. Well, if I come back to that in a second, if you think of the integral of u to the power u to the power 4 du, okay, you're going to get 1/5 u to the power 5 plus c. Now that u could be anything in terms of x. In this case, I'm just choosing it to be 2x plus 1. So our answer is going to look like that. Okay, so initially I'm going to write down the 1/5 u to the power 5, so 1/5 2x plus 1 to the power 5. Okay, I'll put in the plus c in case I forget, and I know the answer is going to look something like that. Okay, do you know what the actual coefficient is going to be? If you do, then you've really got the hang of this. Okay, the actual coefficient is going to be 10th. Okay, now let's just take a look to see why that is. Okay, if you start off with y equals 1/5 2x plus 1 to the 5, and you differentiate that, hopefully you're getting really good at the chain rule now. You got the 5 multiplied by 5th, which is just 1. So you have 1 times 2x plus 1, decrease the power by 1 to the power 4. Then, because it's the chain rule, differentiate what's in the brackets, you get 2. So you'd multiply that by 2. But hang on, in the actual question, there is no 2 there, is there? So you get divided by 2. Okay, so if you were thinking, I know what this coefficient should be, it is 1/10. You're absolutely right. It is 1/10. And the reason is, this is explained, okay? Right, hopefully you enjoyed that. Sorry for the 1 or 2 slips of the tongue, but well, hey, a bit like a live lesson, I suppose. Okay, I didn't re-record it just because of that. This is my 3rd attempt. Yeah, I won't show you the outtakes because there was a bit of naughty language. All right, see you later.